Most of us have confusion about how many panels are needed for a system and different configurations that can be made for a particular capacity of solar inverter. Should we go with full capacity of panels, or can we go with half capacity of panels also? Should we connect in series, or we connect in parallel? How many panels need to be connected in series or how many in parallel for the system to work? On what basis should we decide these? Whether it is based on inverter or panel capacity. Hoping that this video clarifies many things. We can just only use series connection as this one. Or we can go with parallel connection on two or more sets of series connection. Or we can combine multiple strings into parallel connection. This all depends on our understanding of the PV panel specification and the Solar PCU specification that we are supposed to use. PCU manufacturers give flexibility in terms of input panel configuration so that different constraints can be addressed with changes in design. The designing depends on different aspects like shaded area during installation, lack of space to accommodate all panels, customer asking for phased installation, future expansion, decrease in capacity, cost of panels are some reasons. First thing we should look at will be the solar panel specifications. Check for the VOC of the panel. In this example, we can see a 500 watt panel has a VOC of 49.78 volts. We will round it off to 50 volts for our example purpose. At the same time, we take out the PCU inverter specifications and look for the solar PV input section. Here we are checking for maximum PV power and the input VOC range. You can see here two capacities of PCUs and their respective specifications. 7.5 kVA has VOC range of 250 volts to 400 volts and 10 kVA PCU has VOC range of 300 volts to 500 volts. So, now let us understand the configuration using the main specification VOC. We will also try use max panel wattage in the following examples. Please keep in mind that this is only for the off-grid PCUs only. Our aim is to make sure that we adjust the panel configuration to match with the specification of the inverter. The output of the panel connections should match to the inverter or PCU input capacity. So, now let us understand the configuration using the main specification VOC. We will also try use max panel wattage in the following examples. Please keep in mind that this is only for the off-grid PCUs only. First thing we should look at will be the solar panel specifications. Check for the VOC of the panel. In this example, we can see a 500 watt panel has a VOC of 49.78 volts. For simplicity of understanding, we'll round it off to 50 volts for our example purpose. At the same time, we take out the PCU or inverter specifications and look for the solar PV input section. Here we are checking for maximum PV power and the input VOC range. You can see here two capacities of PCUs and their respective specifications. 7.5 kVA PCU has VOC range of 250 volts to 400 volts and 10 kVA PCU has VOC range of 300 volts to 500 volts. We will use two main specifications in this example, both for panel and PCU. These are mainly the VOC and max power, though there are other factors also to be looked at. VOC and max power are the basic things to look for. In this example, we are considering 500 watt panel with VOC as 50 volts. In this example, we are considering PCU VOC voltage range specification as minimum 250 volts to maximum 350 volts. As an example, we will take a PCU or inverter with input specification of VOC is equal to 250 volts to 350 volts and try to adjust our input for the lowest range, that is 250 volts VOC. In this first example, we are trying to match the minimal range of input VOC, that is 250 V. Hence, connecting 5 panels of 500 watts is the minimal configuration needed for the system to work. Note that series connection of 5 panels of VOC is equal to 50 volts will give total output of 250 volts. Voltage adds up in series. Here, the system is underutilized compared to its capacity of 7.5 kilowatt. In this next example, we still want to go with 10 panel setup, with 2 sets of 5 panels in series, which means VOC of 250 volts, as voltage remains same in parallel connection. This way we can get 5000 watt output to PCU and we are matching with its minimum VOC requirement of 250 volts. However, we are not up to the full capacity of panel and the PCU. So let us explore another option. This is the full configuration, where we make use of full capacity of PCU in terms of panel wattage. This makes 7500 watt panel. We have 3 strings in parallel. Here input VOC voltage is 250 volts, and it also matches to max panel wattage. Note that when you combine strings in parallel, the ISC will add up, and in cases where PCU specification is giving max ISC, we should make sure that ISC is within that range when we are connecting strings in parallel. In this example, we are trying to give input of VOC is equal to 300 volts to the PCU, and this is within the specified range for the PCU. This will still work. However, this is not full capacity for the PCU input requirement. We can also make parallel of 2 6-panel series and make up to 6 kilowatt input. Note that we are exploring different configurations that will work. This is with 7 panels. This is not a practical scenario because PCU will be underutilized. However, it will still work. Example 8. This is another good combination which utilizes almost the maximum PCU specific requirements, where in max range of PCU, which is VOC is equal to 350 volts is satisfied, as well as near to maximum wattage of 7500 watt can also be matched. Ideally, if the PCU range was 7000 watts, this would have been a perfect match. Once again, we have tried to optimize based on our example specifications. All these examples can be used based on the technical constraints and customer requirement. Hopefully this clarifies many things. Please leave comment so we can explain better in next videos. Let us take a look at specifications of different PCU manufacturers. In this example, PCU input range specifies the max PV input current also. So we have to make sure the total ISC for connection going into PCU is within the range. When there is no ISC limit specified, go with the max panel wattage required in specification. In this PCU specs, only the VOC range is specified. So we need to ask the PCU supplier about the max panel range or ISC or max panel wattage. Since it is a PCU, its capacity, VA, will be the maximum capacity range. That is, if capacity is 5000 VA, the max panel wattage required will be 5000 watts. This specification is same as our examples. VOC and max power mentioned. Try to have more of parallel strings with matching IOC to get the best efficiency. Look for inverters that specify max ISC. This works better in shaded conditions. Try to go with the highest range. That is, if VOC range is 250 to 400, try to go towards higher range which is 400 volts for better efficiency. Make sure you have addressed all specifications, so that the input matches with inverter-specific limits like VOC, VMP, ISC or max watt power.